Shubham, you corrected one thing, so that's good. So other students also have to observe like that. You can give suggestions like that, okay? Because sometimes I may be in other works, I may not observe everything, okay? You also should be active. Okay, continue, Vaishnavi.
Good evening, sir. A peaceful good evening to all of you. Myself, Vaishnavi. I am from Produttur. Now I am pursuing BTech final year in the stream of ECE in Government Institute of Technology and Management for Women. Now today I am giving presentation on types of logic gates in digital electronics. Logic gates. It is a electronic circuit. It works like a digital switch, like on and off. For example, we take any electronic device, it works based on the IC. Instead of IC, we are designing the transistor. Here I am taking a one small circuit. It is a transistor. Instead of transistor, we are designing logic gates, whatever we require. So it is an transistor. Each transistor has three terminals. Those are emitter, base, collector. When the power supply starts from here and end to here, then LED will be on. Then the power supply starts here and the base terminal is on when connection is formed between the emitter and collector. Then LED will be on. Otherwise, the power supply starts from here but base terminal is off. Then the connection is not formed between the emitter and
Vaishnavi,
collector.
once again
So
share
power
the
supply
screen.
starts.
Once again share the screen. Screen not coming. Your presentation is good.
So
Yeah, once again.
okay. Sir, no, sir.
Yeah, now okay. Continue. Yeah.
From starting onwards, sir.
You can continue from there. No problem.
Okay. So I am taken here one small circuit. So inside of a transistor, we are designing different types of logic gates, whatever user requires. So it is a transistor. Each transistor has a three terminals. Those are emitter, base, collector. When the power supply starts from here and end here, then LED will be on. Otherwise, LED will be off. The power supply is started. The base terminal is on. Then connection is formed between the emitter and collector. Then automatically LED will be on. Otherwise, the power supply is started here, but base terminal is off. Then connection is not formed between the emitter and collector. So the LED will be off. So like that, in any electronic circuit, it works like a digital switch. Digital switch. That is a logic gates. We have different types of logic gates. Those are basic logic gates, universal logic gates, derived logic gates, degenerated logic gates, non-degenerated logic gate, wide logic gate, alternative logic gate, tri-state logic gate, enable or disable logic gate. Now we seeing one by one. First one is a basic gates. We have three basic gates: AND gate, OR gate, NOT gate.
Vaishnavi, slides not changing. Are you changing at your end slides?
Yes, sir.
Okay, okay. Maybe then network issue. Continue, no problem. Okay.
I will share again, sir.
Yeah, once go to next slide, we'll see. Second slide. It is on first one. Okay, continue, no problem. Sometimes due to network issues
Now,
may happen. Yeah, yeah, continue.
now
Continue.
it is an AND gate. Yes, AND gate means it will produces a high output when all the inputs are high. Otherwise, the output is low. And the expression is x equals to a into b. We normally remember AND gate means to multiplying of all inputs, whatever you have. Here I am taken as two input AND gates. The input terminals are A and B, and output is to multiplying of inputs means A into B. For example, 0 into 0 we get 0. 0 into 1 0. 1 into 0 0. 1 into 1 1. Like this AND gate will be works. Coming to the OR gate. OR gate means an OR gate produces a high output when any one of the input is high. It produces a low output when all the inputs are low, and its expression is x equals to a plus b. We simply remember OR gate means addition of all inputs. So here I am taken two input OR gate. Here inputs are A and B, and outputs means sum of two inputs means A plus B. Coming to the truth table, 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 also we get 1. This is about NOR gate. Coming to the NOT gate. NOT gate means just inverse the input value. For example, 0 is the input, inverse, then we will get 1. 1 is the input, inverse, we get 0. This is a NOT gate. Next, we are going to the universal gate. Universal gate means we have two universal gates. Those are NAND and NOR. First, I am taken NAND gate. NAND gate means we know AND gate, OR gate, NOT gate. Just we add gate with AND gate. That is NAND gate. Here output 0 only if all inputs are 1. Here see in diagram AND gate plus NOT gate. This comes under NAND gate. Next going to the NOR gate. NOR gate means NOT plus OR gate, and its output 1 always if all inputs are 0. Simply take as OR gate. OR gate output will be connected to NOT gate. It is comes like NOR gate. Next we are going to the derived gates. Derived gates means from one logic to deriving another logic. For example, NOT gate from buffer, NAND gate from AND gate, NOR from OR gate, like that. We know very well. Recently we seen AND gate and NOT gate plus deriving NAND gate, like that. One logic to deriving another logic. That is a derived gates. Next we are going to degenerate gates. Degenerate gates means do not fully dependence on both inputs. Means whatever input we have, the output will be not dependence on the all inputs. That is a degenerated gate. For example, here I taken the AND degenerated gate. It has inputs A, B, C, D. AB for one AND gate, then output is Y1 equals to AB. And CD for second AND gate, then output Y2 equals to CD. And Y1 and Y2 are connected to another AND gate. Then output Y equals to A, B, C, D. This is a AND gate for gate. Coming to the non-degenerative gates. In non-degenerative gates, the output is dependent on all inputs. There is difference between degenerate and non-degenerate. In degenerate, the output is not dependent on all inputs. In non-degenerative gates, the output is dependent on all inputs. Here I am taken one example. It is an AND gate, has the inputs are A, B, then output will be get AB, and CD AND gate given output will be CD. Then y1 and y2 are given to the OR gate. Then output is AB plus CD. This is example for non-degenerative gate. Coming to the wide gate. Wide gate is also called as widen and wider. Here I am taken wide and example. Okay. It consisting two AND gates in first level, and in second level another AND gate will be consist. In first AND gate the inputs are AB, then output is AB. And second AND gate has inputs are CD, output is CD. Y1 and Y2 are connected to the second level of AND gate. Then it produces ABCD as output. Next we are going to the alternative gates. Alternative gates also called as a bubbled gate. Its meaning applying a complement to the all inputs of a logic gate is known as a alternative gate. For example, here I am taken bubbled OR gate. Okay. The A will be bubbled, then A bar, and B is comes B bar. It is an OR gate, so it's come like A bar plus B bar. It's equals to the NAND gate. NAND gate inputs I taken A, B. Its output is A into B bar. It's written as also A bar plus B bar. So in this, the bubbled OR gate is equals to the NAND gate. Next, we are going to the tri-state gate. In two-state gates, we have outputs are either 0 or 1. But tri-state gates, we have outputs 0, 1 or high impedance, nothing but Z. It has controlled input. A is an input, and here I am taking output as F and control input as C. You can see in here truth table, when control is 0, then output will be Z. When control is 1, is the output will be dependence on input. Whatever you apply in the input, that value will be comes as a output. This is tri-state gate. Coming to the enable or disable gates, controlling the using an additional enable input. For example, enable is 1, then it will produce as output as either inverse or whatever you are applying input as it is getting output. If enable is 0, then output getting as 0 or Z. Coming to the summary, we have basic gates are AND gate, OR gate, NOT gate, and universal gates are XOR, XNOR. Derived gates are XOR, XNOR, and special gates are degenerate gates, tri-state, enable or disable, byte gates, and alternative gates. Coming to the applications of logic gates, these logic gates are we are used in robotics, communication systems, and controls LEDs like that. And thank you.
Yeah, completed, right?
Yes, sir.
Okay, okay, good, very good presentation. Maybe due to network issues, slides not changed, but I think you prepared very good PPT. But the highlight thing is your starting introduction yourself, and the complete during complete starting to ending presentation is very pleasant, very good. Yeah. So students, now I have system relaxation. So tomorrow, Kiran, Kalyani, Manisha, Sai Kirtana, and P. Sirisha. Five people are there. You can give presentation tomorrow. So tomorrow also we'll have presentations only, so that day after tomorrow onwards we can concentrate on classes. Okay. So meanwhile today I will send one lecture, sequence circuits, already my revision recorded lecture, that I will send. So go through. Okay. So that parallelly you can learn content also without wasting any time.